water, the amount of water that are used for this purpose also, we will include that water comes under the crop water requirement. And sometime if you are willing to, suppose you are going and you are knowing that after the investigation that the field is having salt related problem, so you need to leach out this salt from the field now. So for that purpose, you need to apply the water, irrigation water, and that water will also come under your water requirement. So finally, you can say that water requirement is consumptive use, application losses, what I told you here, percolation, seepage, and runoff, and water need for special operations. These all will included under the water requirement. So water requirement always will be greater than crop water requirement, because in water requirement you can see how many components are included, and in crop water requirement E plus T plus metabolic activity, these are the differences. Now we will discuss about the irrigation requirement. So here you can see we now understood what is the water requirement. Okay, so suppose your fields require 10,000 mm of water as a water requirement. So this 1,000. So this 1,000 may be supplied by the sum of your effective rainfall, and some of will be contributed from soil moisture. Okay, soil moisture. So the fraction of the water that will be contributed by effective rainfall and soil moisture storage, we have to deduct. Suppose we got 400 mm from these two sources, effective rainfall and soil moisture storage. So apart from that, 600, this is our deficit area, means we are having now deficiency of 600 mm. So this would become the part of our irrigation requirement. Okay, so that's why you can see here what it is saying that irrigation requirement is a total amount of water applied to a field to supplement rainfall and soil moisture contribution to meet the water need of crop for optimum growth. Okay, so for a optimum growth of the crop, there was 1,000 mm of the water, and of that 400 was contributed from effective rainfall and soil moisture storage. So 600 mm will be your irrigation requirement. Now there is another term, that is a net irrigation requirement. So what is the net irrigation requirement? Actually is the amount of irrigation water just required to bring the soil moisture content in the root zone depth of the crop to the field capacity. So actually when suppose we applied 600 mm as in the form of irrigation. Okay, so after the application of 600 mm, we found that 200 mm that lost in the form of percolation or any other methods. So only when we deduct this 200, then 400 again mm only retained by the soil. Okay, and that become the part of field capacity. You know, now 48 hours after the irrigation, when you apply, suppose today water you applied, so after 48 hours, the moisture that are retained by the soil, that is called, the state is called field capacity. Means the moisture, those are held by the soil against the gravity. When gravitational energy will be equal, now gravity cannot work at that potential, and that is, we all are knowing 0.33 bar. When our soil water potential reaches at this potential, soil water potential reaches at this moment, at that moment our gravity will stop, and the moisture that are retained at that time is this is called our field capacity. So the amount of water that are retained at this soil water potential, that is actually called net irrigation requirement. Thus, the net irrigation requirement is the difference between the field capacity and soil moisture content in the root zone before the irrigation. Okay, so even you can also calculate by this way. Suppose 26% is your field capacity of your field, and you are having right now 12% moisture in your field. So how much it is required? Means 14%. Again, you need to bring your field up to 26%, because you are knowing that when the field capacity happen in your field, your moisture content at the time is 26%, and you are right now having only 12%. So for 14%, that will become your net irrigation requirement, because when you will apply 14%, then your field will reach 26%, and that is called field capacity. And we always consider field capacity is equal to 100% of available soil moisture. You got at the field capacity, the field when you will go for the gravimetric moisture content estimation, you will find that 26% will be the your water content in volumetric basis, and this 26% we consider it as a 100%. Okay, and when it again go 50% depletion of available soil moisture, then we used to irrigate the most of the crop. But some of the crop they go 65% depletion of available soil moisture, and up to that point also they will grow continuously. After that, grass irrigation requirement is the total of net irrigation requirement and other losses such as conveyance, distribution, and application. So if someone is asking what is grass irrigation requirement, so that's simply what you are net irrigation plus convenience losses, distribution, and application. Okay. 1 minute, जरा एक फोन आ रहा है मेरा, मैं करता हूँ. Now we can see here the crop water requirement, the water requirement of different crops. So if suppose we take the example of rice, you can see, you may be knowing that water requirement of rice is 1100 to 1250 millimeter. Okay, and if you see the daily consumptive use of rice crop, so that is varies 600 to 6 to 10 mm. This is daily consumptive use. Consumptive use means transpiration losses and evaporation losses from rice field per hectare, that every day rice use 6 to 10 mm as a consumptive use of the water, and total water that is ranges 1100 to, and this is the what I told you here, in the different agroclimatic situation. Of that, if you divide this, you can see here 3%, or you can say 40 mm is used for the nursery, because rice required nursery preparation. So we use our 40% out of this 1250 mm, 40 mm we use in nursery for nursery raising, and 16%, 200 mm, that is required in special operation like land preparation. As I told you, rice require puddling. Okay, and 81%, that is remaining 1000 mm, that field irrigation for the crop. So crop will use it as a, but you can see here 16% and 4 here near about 3%. That is 19% we use before the transplanting. Okay, so because of that, when we change our rice cultivation from transplanted rice to direct seeded rice, so this advantages we will get 16% and 3%, means 19% directly we can save here in the case of direct seeded rice. If anyone asks you what are the advantages in the terms of the water, especially, you will get when you will go from the transplanted rice to the direct seeded rice. So your answers should be very precise, that you can say that, sir, in nursery preparation, we use 3% of the water, we have 40 mm, and 16% we use for the 200 mm you use for land preparation. This quantity of the water directly we can save if we go for the direct seeded rice, because these operations are not required in the case of direct seeded rice. Now we will talk about the groundnut. If you see the groundnut total water requirement is 500 to 550 mm, and evapotranspiration is low during first 35 days after the sowing and last 35 days before the harvest, and it is reaching maximum peak water requirement is when there is a peg penetration and pod development stage. Means when pegs penetration flowering will start, and then gynophore will start to develop, peg will penetrate in the soil, and then pod development will start. So at that time, moisture means water is very important for the groundnut. After the sowing, irrigation, the second irrigation can be scheduled 25 days after the sowing, then 4 to 6 days after the first hand hoeing, and thereafter irrigation interval 15 days is maintained up to the field flowering. Okay, the first irrigation you will give after 25 days after sowing, and you can say that when the 4 to 5 days after the first hand hoeing, and you should always be careful about the hand hoeing. You should not do the hand hoeing when the groundnut reaches for the flowering, because it will disturb the peg. During the critical phase, what I told you, critical phase means when your peg's development will start and pod development will start. During that phase, you can see your interval should be less than this normal 15 days. Now it should be 7 or 10 days depending upon the soil type and climate. And during maturity, again, you can maintain up to the 15 days irrigation interval. After that, we will discuss about the finger millet. So these are this is one of the drought resistant and tolerant, you can say, drought tolerant crops, and this require very less amount of the water, only 350. Naturally, this is a crop of dry land area, and pre-planting irrigation at 7 to 8 centimeters is given, and the third day after transplanting, life-saving irrigation with a small life-saving irrigation. Only a small quantity of the water is sufficient for uniform establishment. Water is then withheld for 10 to 15 days after the establishment of the seedling for healthy and vigorous growth. Subsequently, 3 irrigation are essential at primordial, initiation, and flowering and grain filling stage. So this is the case for the finger millet. Now we can discuss about the maize. This requires somewhat more water as compared to the finger millet. So your maize is more sensitive to both deficit and excess. When water will deficit, it will show symptom very early. When the water will exceed in the field of the maize, then again it will show water logging symptom very early. So that is why it is sensitive, both excess and deficit irrigation. And water requirement of the maize is higher, but it is very efficient in use of the water use. Growth stages of the crop, the maize crop are sowing, 4-leaf stage, knee-high stage, and grand growth, tasseling, silking, early duff, late duff stage. These are some of the stages. But apart from that, you can see here the reproductive stage is started when it is started tasseling and silking stage. But these are some of the vegetative phase, and After that, silking and duff. This is late duff. So after duff stage, this is again not much sensitive. But what you can say, tasseling and silking and duff, these are the very sensitive stage. At this stage, you must need to apply the irrigation water. Crop uniformly require water in all these stages. Of this regarded testing, silking and early duff stage are the critical. As some same thing what here also this is saying. Now this again another crop we will discuss about the sugar cane. Sugar cane, you can see it is having very high water requirement, 1800 to 2200 mm. And why it is so? Why it is require more than rice? Can you tell anyone? What is the main factor? The water requirement of this sugar cane is higher. The reason behind is the duration. Most of the cases you may find that 260 or 270 or 300 days is the required for the a normal exali. A sali will take more than 1 year. Okay, so you can see here some of the critical phases, like formative phase. 120 days from the planting is the critical period, because this is a very important. At this stage, if you will not apply the optimum water, so what will happen? Germination will not be uniform, and optimum number of tears per unit area will be lesser. So that is why this stage is very important, because at this stage the moisture is more critical part this phase. The response for applied water is more during this critical phase, during which the crop need higher quantity of water comparing to other two phases. Like the water requirement, number of irrigation are higher during these phases, and as there is no secondary thickening of the stem, elongation of the stem as seen for the storage of the sugar, it is desirable to maintain optimum level of moisture during the grant growth period. Okay, so when the grant growth started in the your sugar cane, during that time water is the most important, because your photosynthesis are translocated, and sugar will at that time the translocation is very important, because ultimately you want to get the sugar content. So that is why this grant growth phase is very much important, and responses for the water is less in this stage, and this will be still less in the ripening. At what I can say, after the when your sugar cane will be start to ripen, at that moment of the time your irrigation will not play much important role. During the ripening phase, as harvest time approaches, the soil moisture content should be allowed to decrease gradually, so that the growth of the cane is checked and sucrose content is increased. Actually, when your sugar cane will approach for the harvesting, when you know that it is approaching toward the maturity and you are trying to harvest, so at that time your motto should be to stop irrigation, decrease the moisture content in the field, so that your moisture content means in canes should be lesser, so sucrose content will increase at the time. Okay, so basically sugar cane is a sugar crops from where we use sugars. So basically our purpose is to extract more sucrose from this cane. So that's why when the harvesting approaches, our basic aim should be to decrease the moisture content in the field. Now we will discuss about the cotton, and you can see the cotton required 550 to 600 mm of the water, and cotton is sensitive to soil moisture condition. Little water is used by the plant with early part of the season, and more water is lost through the evaporation than transpiration. At early phase, always in all the crops, either if you will take any crop, so at early phases, early stages of the crop, your canopy development will be less. So because of the canopy development is less, so most of the soil are exposed to the sun. So evaporation will be more at early phase. But when your crops grow and more canopy increase, so at that time most of your field will be covered by the leaf of the crops. So at that time transpiration will be more as compared to evaporation. But at early phase, evaporation is more as compared to the transpiration. At the plant grows, the use of water increases from 3 mm day per, reaching at a peak of 10 mm per day when the plant is loaded with the flower and ball. So you can see here what the water requirement what consumptive use, what you can say from 1 hectare of the area, it varies from 3 mm per day at an early stage, and when plant reaches at a peak growth phase, means grand growth phase, when the flowering start and ball development start, at the time the most of the field are covered with the leaves. So at that time the consumptive use of the cotton is about 10 mm per day. Water used during the emergence and early plant growth is only 10% of the total requirement. So add two phases here. You can see the emergence and early growth phases, plant growth phases. Cotton require only 10% of the total water requirement. So you can say here the 10% means 55 mm is only required during this phase. Ample moisture during the flowering and ball development stage is essential. In the early stage as well as the end of the crop require less water. Water requirement remain high till the ball development stage. So always consider the flowering and ball development. This is the very important stage, because at this time lint development, you are basically interested for the cotton to get more lint. So at this time, if you are flowering time and ball development time, if any moisture will moisture content will be reduced, or plant will face the drought or scarcity of the water, so ball development will be not, and finally it will reduce your lint content. If the excess water is given in this stage, other than the critical stage, it encourages the vegetative growth, and because it is an indeterminate plant, thereby ball setting may be decreased. So cotton is actually indeterminate. You know what is determinate and indeterminate crop? Anyone can answer what is determinate and indeterminate crop? Anyone? What's the difference between the determinate and indeterminate? Barade Om, Barade. Who is this? Are you hearing me? Are you listening me? Barde. Kalpana Bangar.
Unmute, or you can also write your answer in the chat box.
Actually, just the intention of my asking the question, want to see your interest. Are you really listening me or not? That's why I asked the question. So no issue. Again, we were here. Indeterminate plant. I was asking about the indeterminate plant. Means indeterminate plants, those where the flowering, vegetative stage and reproductive stage is not clear. Means vegetative stage will also continue and flowers will come. Again, suppose this is a plant, a cotton plant. The flowers will come. Again, it will grow. Then again, flower will come. So reproductive and vegetative phase, those are mixed together. No clear-cut distinction. Okay, vegetative growth will also continue and flowers will also come. Okay, but determinate type of the plant. First of all, plant will complete the vegetative phase, and then it will comes after a definite period of the time, it will come to the reproductive phase. Example, rice है आपका, wheat है. These are the example of determinate. Okay, but cotton is indeterminate. So that is why excess moisture you should not maintain, because simultaneously in cotton vegetative growth will also continue, because it is indeterminate. As I told you, if you will apply more water, so it will promote vegetative growth more as compared to your flowering or ball development. That is why moisture excess should be avoided in the case of cotton at the time of the most critical phases, what I told you, at the time of flowering and ball development. And irrigation is continued until the first ball of the last process open, and then irrigation is stopped. And we will continue it when up to that the first ball form, and after that we will stop there. That is why it is required. You should not mix, because as I told you now, this is an indeterminate crop. So at the time of the flowering, again vegetative stage again will be continue in cotton. So if you apply excess water, then there will be the problem. Now we can talk about the sorghum. In the case of sorghum, water requirement is 350 to 500 mm. The critical period of water requirement is booting, flowering, and dophy stage. And the crop will be irrigated immediately after the sowing. And next irrigation is given 15 days after sowing to encourage development of a strong secondary root system. And irrigation prior to heading and 10 days after the heading is essential for successful crop production. So this is the stages where the sorghum is required, even though sorghum is also drought resistant crop. And pulse, if you see, the pulse require very less amount of water, 200 to 450 mm. And mostly if you see the pulse crop, those are confined to the Bundelkhand area and dryland area. Those are marginal land where the pulse are confined. Why? Because they basically the water requirement of this crop is very less in all the pulses. Mostly the pulse are grown under rain-fed condition, you can see here. And some pulses crops like red gram, black gram, green gram are grown in summer season as irrigated crop, which needs 3 to 4 irrigation at a critical stage like germination, flowering, and pod development stage. Only the pulse required irrigation attention when we will move for the summer sowing, like as I told you, red gram, black gram. Because at the time of the summer, the temperature peak is very high. So that's why without irrigation, it is not possible summer. So finally, in the table form, you can see here these are the durations and rice duration 135, and this is water requirement. Groundnut 105, sorghum 100 days, and this is the water requirement. Sugarcane, as I was telling, more than 365 days exali, and that is why you can see because of long duration, it is having 2000 mm. And number of irrigation, even you can see. This is recommended irrigation for that and all the crops. Now we will we discuss water requirement, net irrigation requirement, and the terminology and what are the water requirement of different crops. And now in this slide we will discuss about how we can go for the determination. What are the conditions that are very much, if you are really interested to calculate the crop water requirement. So what conditions should be in your field? First of all, if you are interested to calculate crop water requirement of any crops, your crop should be uniform. That should be actively grow. There should be complete standing the ground, and the crop should be free from the disease. Because if the crop leaves will be affected with the disease, then that will be ineffective leaves, and ineffective leaves will not transfer much of the water. The soil should be favorable for that particular kind of the crop, including the soil fertility and in the context of the water. So there should be no limitation. So these are the idealistic conditions required for the crop water requirement. And what are the different factors that will affect the crop water requirements? Here you can see climate. As we know, the temperature, relative humidity, wind velocity. These are the very important factors that will determine the amount of water that will be transpired from the field in the form of evaporation and transpiration. So when temperature will increase, definitely ET will be more. When relative humidity will be less, then ET will be more. And wind velocity, if is more, then again ET will be more. So water requirement will be more. So that's why you can see this is the low relative humidity and high temperature found in dryland area. That's why the water requirement when you will go, when you will give the water in that area, that will immediately finish from the field. That's why dryland area and rain-fed area is always advisable, especially dryland area I'm talking. That is always advisable. Before taking the crop, you must have to understand what is the crop water requirement of a particular crop. So according to the availability of the water resources and understanding the problem and constraint of your area, you should choose the crop. And if you are choosing the crop those requiring more water, and if you are sowing in that area, then definitely you will fail in your crop production. After that, you can see the crop is also one of the factors that affect the crop water requirement. Some of the crops, as I told you, that's having long duration, long canopy. So definitely that practices that kind of the crops require more water. And already some are drought lover and drought resistant and drought tolerant. So they are the crops also affect the crop water requirement. And even the stages, crop growth stages also affect the crop water requirement. If some of the crop those are having more vegetative phase, and then definitely that will require more water because when the vegetative phase will be more, duration will be more. So even the growth stages also your affect the crop water requirement. Then crop management practices like tillage, fertilization, and weeding. These are some of the management practices. Can anyone tell how the weeding will affect the crop water requirement and fertilization and tillage? The role of tillage is here. When you will till the soil itself will act as a soil mulch because you are disturbing the capillary tube. You will disturb the capillary tube. So when the tillage happen in the field, so the capillary tube, those are responsible for the water to uptake from lower bottom to upper area, will be break down and the soil act as a soil mulch. Fertilization, as I told you, you should avoid the use of excess nitrogen and you should give emphasis on some potassic and phosphatic fertilizers so that your transpiration can be checked. And weeding, how it will be happen? If the weed population will be more, then definitely the crops will be lesser and most of the area will be covered by the weed, and crop transpiration coefficient is many fold more of the weed as compared to the your crop. That is why weed will transpire more water from the field. What is transpiration coefficient? Anyone tell? Anyone can tell? Can anyone tell? Transpiration coefficient means for producing a gram of dry matter in a weed that needs more water, will transpire more water to produce a gram of the water, a gram of biomass as compared to the your crop. Now we will discuss about the reference crop evapotranspiration. What is the reference crop evapotranspiration? So reference crop evapotranspiration is the rate of evaporation from a large area covered by the green grass 8 to 15 centimeter tall, which grow actively, completely says the ground, which is not sort of the water. Okay, and reference evapotranspiration is usually expressed in millimeter per unit of time. That may be mm per day, mm per month, mm per season, and especially grasses we used to take as a reference crop. Suppose you want to calculate a reference evapotranspiration, what would be the potential evapotranspiration that can happen from a particular area? If you are really interested to estimate that, then you need to consider some of the specification what are given here. You need to grow grass over this, and here the field should be always at a field capacity during the actively growing period when your crop is attaining 8 to 15 centimeter, and whole the field should be covered by the vegetation, by this grasses. So the amount of water that will be lost from this field, that we will call it as a reference evapotranspiration or potential evapotranspiration, and that we can express it as a mm per day, mm per month, or mm per season. So there are some of the methods those which you can use for estimate the reference evapotranspiration. As I told you, the experimental method using an evaporation pan, theoretical method using some climatic data, like example I'm giving you Blancy and Friedl's method we use for the determination of reference evapotranspiration. So how you can use by using pan evaporimeter? Just simply pan provide a measurement of combined effect of temperature and humidity and wind speed and sunshine on the reference crop evapotranspiration of the crop. So you need to a class, this is the pan evaporation pan, you need to fill here, and this is 25 centimeter height and 5 centimeter of that wooden platform, and here the measuring devices you may have to fit it, and this is having dia, you can see 120.2 centimeter. This is the standardized pan, class A evaporation pan, and you can estimate the actual evaporation that may be happen in a particular environment and climatic condition in a field area. So these are some of the methods, and this is all about the water requirements and how we can go for that. So hope you enjoyed this lecture, and after that we will move for the another. And the topic. So hope you enjoyed that, and if I want that anyone, if you are interested, you may interact. If you are having any queries regarding the previous lecture, you can ask. I will give you 5 minutes. Then we will start from the irrigation scheduling. Anyone? Prajwal. Pratiksha Kale. Here is the some of the message also. Since PPT today, sir, all this is the PPT will share with you all. Okay. Okay, if no questions, then we will move for the next topic. Oh, sorry. Now we will discuss about the irrigation scheduling. So what is the irrigation scheduling? Irrigation scheduling is the process through which you can just when to irrigate and how much quantity of the water you need to apply. This two answer is very important in for the irrigation scheduling. So there are the some different criteria, those are used. But before that, we have to understand what are the advantages you will get if you will schedule the irrigation. Okay, so it enables the farmers. It enables the farmers to schedule water rotation among the various fields to minimize the crop water stress and maximize the yield. The first of the answer you will get from the irrigation scheduling is, suppose you are having variety of the crop in your farm or in your field. So you can judiciously use your water to that crops when you will know that when to irrigate, because this answer will save your water and you can judiciously use your water for the other crops. Those may be having the high water requirement at that moment of the time. Okay, so it will reduce the farmer's cost, water and labor. So when you will increase the water use efficiency at your farm, so there's two cost you will minimize and even labor cost. Lower fertilizer cost by holding the surface runoff. So many times what happen when we apply excess water in the field, when we are not knowing how much quantity of the water we need to apply in the field, what happen because of the leaching and runoff, when we excessively apply, or fertilizer use efficiency also go down. So when you will apply optimum water, so your fertilizer use efficiency will also increase, and then that will lead lesser fertilizer use, and it increases net return by increasing crop yield and crop quality. It minimizes the water logging problem, as I told you. It assists in controlling root zone salinity problem. Before yesterday also I told you that most of the Haryana and Punjab, they are facing the problem of soil salinity, and it's happened why they excessively irrigated their field by the use of canal water, because they got free electricity, they got free of canal water. So what happened? Water logging situation happened, and because of seepage from the canal and excess use of the canal water, what happened? There was salinity problem. That's why CSR is Central Soil CSSRI, one of the ICR institute, was established at in Haryana for this for addressing this problem. So it results in additional return by using save water and irrigate to irrigate non-cash crop. So you will get you will save the water just you are knowing, when you are knowing that when to irrigate, to whom irrigate most appropriately, so you will catch more by just using less. So there are the different criteria that are available now that you can use to schedule the irrigation, schedule the irrigation, like soil water regime, climatological, plant indices. This is the three major category. So under the soil water regime, you can see feel and appearance, depletion of available soil moisture, and soil moisture tension. This is the soil water regime approach to schedule the irrigation. After that, the climatological. Under the climatological, you can see cumulative pain evaporation, what I shown you in the last lecture. Just that can be also used for the estimation for scheduling time, irrigation scheduling time. And irrigation water and CPE ratio method is one of the method. Through that, you can go for the irrigation scheduling. And most commonly is plant indices, that is visual symptoms, soil cum, sand mini plot, and plant population, growth rate, relative water content, plant water potential, canopy temperature,
Hello?
and indicator plant and critical growth
Vipin
is
sir,
this. Yeah,
slides are not moving, I think.
slides are moving.
Not moving.
Okay. 1 minute. Sorry. 1 minute. 1 minute. Sorry. I want to share. Okay. Yeah, now visible some irrigation
Yes.
scheduling criteria now visible now.
Yes.
So what I was talking, plant indices like visual symptoms, now it is visible now.
Yeah.
And soil cum, sand mini plot, plant population, growth rate, relative water content, plant water potential, canopy temperature, indicator plant, and critical growth stages. So these were. Now we will discuss about soil water regime approach. So what is soil water regime approach? In this approach, the water available soil water held between the field capacity and permanent filtering point, we consider it as available water. Alternatively, soil moisture tension, the force with which water is held around the soil particle, and sometimes used as a guide to for timing the irrigation. So soil in the soil water regime means, I told you that the water, those are retained in between the field capacity and permanent wilting point. That is your actually the water available for the plant, and the plant will use that. And by the force, your soil surface will retain the water. That is the tension, soil water tension. That assessment is also one of approach to that. You can go for soil irrigation scheduling. And feel and appearance of the soil. This is one of the oldest and simple method of determining soil moisture content. Most of our ancestors, forefather, they were using this technique just by putting the soil from the field, and they are assessing by in their own hand, by visual observation, and just by feeling the soil in their hand. They used to say that now this is time to irrigate. So you can see here some of the how the fine sand and loamy fine sand will appear and will behave in the field and appearance. This is the 0 to 25% depletion of available soil moisture. At that moment of the time, you can see it is completely formed. Ball formation happen, but a lot of the your soil are also attached to your hand. But you can see when it depleted more, 25 to 50%, then less amount of the soil are attached in your hand. Most of that are collected and become the ball. But when again 50 to 75%, then very less amount of the moisture that will be filled by your hand, and most of the soil, the moisture, those will be only in the ball. So this is some of the kind of the experience you will feel in the soil when you will take the soil from your field. So that is actually the very basic and traditional way to say. And these are some of the guidelines for judging the soil moisture by feeling and appearance of the soil. Now, the second is depletion of available soil moisture. In this method, the permissible depletion level of available soil moisture in the effective root, crop root zone depth is commonly taken as an index. So from a particular crop root zone depth, the amount of the water suppose are depleted. As I told you, the field capacity is considered as a 100% available soil moisture level. So if the 20 or 50% are depleted of that, then it is advisable, and it has been calculated by the research finding that this is the time to irrigate the field. So at that moment of the time, you need to apply the irrigation. So here you can see that while at other stages like 50%, and here generally many of the crops schedule irrigation at 20 to 25% depletion of available soil moisture in the soil profile was found optimum at moisture sensitive stages. So it is recommended that those are the moisture sensitive stages, like as I told you, like flowering and pod development, grain formation, duff stage. These are some of the sensitive stages for the crop. So at that time, you need not to allow your soil to deplete more than 25% of available soil moisture. Okay, maximum is 25. If 25% is depleted, then you need to go for the water application. But other stages like your vegetative and other ripening phases, you may allow for deplete up to the 50% of depletion of available soil moisture. So here are the some of the crops and their how much you can deplete, and different locations through the experiment it is given. Maize you can go for 25 to 50% up to depletion of available soil moisture. Sugar again 25 to 65% you can go. Groundnut you can see 25 to 40% you can go. Cotton you can go up to 65%. Sesame 50%. Leafy vegetable you can see that is very sensitive. You cannot go more than 20%. Then it will so that's why it is very sensitive for the moisture. So you need to apply always moist condition of the field. In the case of leafy vegetable, if you are going, you can see even tobacco also is very sensitive. Only 30 it is sensitive. That is why 35% only the depletion of available soil moisture is recommended for that. You cannot go beyond that. It will hamper the leaf quality. In the case of wheat, you can see 50% depletion of available soil moisture we can reach. So now soil moisture tension, as I told you that in the last slide, that soil moisture depletion and the because the water is held around the soil particle by the sum of the forces, and that is we call soil moisture tension. How you can measure that? Through for measuring that, as I told you, soil moisture tension very most commonly tensiometer is the very important tools that you can use, and most commonly you may see here in your university or any places most commonly you. So tensiometer is installed in a pair or one in the maximum rooting depth or another in the below that's rooting zone. So whenever the critical soil moisture tension is reaches, the irrigation is concerned. While the lower one, you can see here, I will show you some picture. Yeah, here you can see this is the plant root zone. You need to apply. You may go many even tensiometer also. It is up to you up to which depth you are interested to measure the soil moisture tension. So basically here it is given like 2 tensiometer. In the first you can see this is for the up to 50 centimeter depth of the soil, and second was for 90 centimeter depth of the soil moisture. So it will measure the tension of the moisture. This will measure up to 90%. This will measure only 50%. So by seeing this reading, you can judge what is the tension of water is existing around the root. And so according to that, you can judge when to irrigate, when your plant will feel the more difficulty to attract the water. So here centibars are given, and the depth it is different crops, and the centibars when this is threshold soil moisture tension value for scheduling irrigation. This is the different crops and their value like tensions are given. For sugarcane, you can see here 30 to 65 centibars. This is the range for the scheduling irrigation in the sugarcane. And maize 25 to 50 bar, and cotton 40 to 50, sorghum 50 to 65, tobacco 30 to 40, soybean 50 to 60, wheat 40 to 50, and potato 25 to 50. So the centibar, you can see the value is very much similar to the depletion of even available soil moisture from the root zone. This value is very similar to that, but this value is your tension value, soil moisture tension value, but that was the percentage. So you can say that the moisture percentage depletion and the centivar value are near about same. Now we can assess through the climatological approach. So in the climatological approach, I told you the different formulas are data required. The potential rate of water losses from a crop is primarily a function of evaporative demand of the transpiration. And in this method, the water losses expressed in the term of either potential evapotranspiration or cumulative pen evaporation. And different climatological approaches are described below, like the Penman introduced the concept of potential evapotranspiration. This is the method through that you can just when to irrigate. The amount of water that is transpired in a unit time by short green crop, as I was telling about that now, potential difference evapotranspiration in the previous slide. The same concept we can use here for scheduling irrigation. Okay. Lysimeter is installed near to your field, okay, and same type of crop cultural practices and soil that we will fill in a drum in a some depth, maybe it will be having 1 meter depth. So the type of the soil that will be nearer to your field, we will fill here also the same, okay, but that drum will be fitted over a some weighing devices, okay. So what crops we will grow here, the same crop we will grow in this drum also. So and all the cultural practice, similar cultural practice we will follow in this drum. So actually we call it as a lysimeter. And so when we will apply the water, it will show the sum of the value, and as the water that will last in the form of evaporation transpiration, the value will change. So this is the one of the way through that you can estimate the evapotranspiration from a soil monolith. Means soil, why we called it a soil monolith? Because we are extracting the some profile from your own field, digging the hole and fitting that drum inside that, and arranging some arrangement there, so that we can measure the weight variation in the field because of addition of water and increment of biomass. So this will help you to determine evapotranspiration from an area. So potential evapotranspiration you can even estimate through this lysimetric method also. And this is the USW class, USW B class A pan evaporimeter, already we discussed in last time. So irrigation water and CP ratio is also one of the approach when you estimate what, suppose you are knowing that this is a water requirement and you calculated this crop potential evapotranspiration of that particular time, and if you are knowing that irrigation water requirement of how much you irrigation water applied, so just by the ratio, by multiplying that to that time, you can judge that this is the right time to irrigate our field. And it is also not having means this method is not suitable for some of the crop, like suppose you are using this for crop requiring only 1 or 2 irrigation, so this is not useful for that crops. Determining timing of the first irrigation and last irrigation is not possible by IWCPE ratio. Under low temperature and frost and salt stress condition also you cannot use this. Now we will discuss about the plant indices approaches. Some of the visual symptoms, those you can see, and through that you can judge the when to irrigate, because plant are already communicate with you how the plant will be in your field, that will communicate with you through the different means by indicators, like sometime it will increase the foliage, sometime it will increase the shoot length, sometime it will fold the leaf. So that are the one of the visual symptoms. Through that you can judge when to irrigate. So in the visual plant system, in this method, visual signs of the plant are used as an index for scheduling irrigation. For instance, plant wilting, drooping, curling, rolling of leaf in maize is used as an indicator for scheduling irrigation. Changes in foliage color, leaf angle is used to time of irrigation in bean. Water stress in some crops lead to appearance of carotenoid, yellow and orange color develop, anthocyanin pigments will develop in that. Shortening of internodes in sugarcane and cotton, retardation of stem elongation in grapes, and leaf abscescence and lack of new growth, redness and terminal growth point of the almonds. So these are some of the crops and what is the crops where some of the indicator that will be visible in your plants when your plant will feel the water stress. So here you can see
Hello, sir, you are not audible.
हेलो
हाँ, now you are.
मैं कह रहा हूँ अभी इंटरनेट अचानक कट हो गया था.
Okay, okay, ठीक है.
I don't know why from my side or from your side, I don't know. So if you go in your field in afternoon, you may see very, very clear that maize will show the rolling appearance. Why? Because maize want less exposure to the sun. That's why that the leaf will roll down and transpiration will be less because of that only. Soil cum sand mini plot technique for soil profile modification technique also you can say. So actually commonly used for scheduling irrigation to the crop. The principle involved in this technique is to reduce artificially the available water holding capacity of the soil profile, or you can say effective root zone there in a mini plot by mixing sand with it. And an area of about 1 to, my slide is visible now. Hello, Dr. Prasad.
Yes, sir, visible, sir.
Yeah. An area of 1 to 1 meter is selected in the field, and pit is means you can say 1 cubic meter area you need to dig, and in that extra 5% sand if you will add. So artificially what you are doing, you are reducing the water retention capacity of your field. So that selected area will show early sign of water deficiency. Okay, and that will act as a indicator for that site. Will that pots will means selection site will be act as a indicator, and then you can decide when to irrigate. This is the procedure written here. The pit is then filled back with the mixture, while filling up to every 15 centimeter layer is well compacted so that the soil in the pit retain the original bulk density as the surrounding soil. Crop is sown normally and allowed to grow as usual with the rest of the field. So the same practice what you are following side by the field, same practice you need to follow in your this pit also. As when the plant in the mini plot show wilting symptom, it is taken as a warning of impending water need and crop field is irrigated. So that site will indicate that okay, because the symptoms of water scarcity symptom you will get very early as compared to the rest of the field. So that will act as an indicator. Now the plant population is also through plant population is also modifying the plant population. You can just the when to irrigate. Suppose increasing plant population by 1.5 to 2 times that of the optimum. Suppose you are increasing the plant population 2 times, than the optimum, what is required for that particular crop. It means that you are promoting more water, more transpiration from a particular area. So that patches will transpire more water because that their population is just doubled. So that will show early symptom of water scarcity, and that point you can use as an indicator for scheduling the irrigation. And this happens because when the more plant are there per unit area, the available water within that zone is depleted rapidly as compared to the other area. This results in dropping and wilting of plant earlier, which can be taken as an indication of water deficit, and accordingly irrigation are scheduled to crops. Okay, after that, rate of growth. Rate of growth is depend on turgor, which in turn is depend on the favorable soil water balance. So the fluctuation in the water tables are reflected by parallel fluctuation in the growth rate of expanding organs. So stem elongation is markedly reduced when the available soil moisture level approaches the critical level, but accelerate again after irrigation. You may see some of the variation in the growth rate. When the water will be less, those plant which have node and internode, so internode elongation will be lesser. They will show because moisture automatically affect the turgor pressure of the cell, and because of the turgor expansion, the growth happen, plants elongate. So this kind of the shortening of the internode you may see in your crops, and that will act as a indicator of when to irrigate. Relative water content, by judging what is the relative water content in your leaf of the crops, you can assess the plant is under the stress condition or in optimum condition. And this concept was proposed by Weatherly in 1950. So this is the instrument through that you can calculate the water relative water content. And even the canopy temperature by the using infrared radiation without touching the plants, just by seeing the variation. Just this is the infrared thermometer. This is so by the use of that, you may see that the ambient environment will have more temperature, and when you will take the reading inside the canopy, the temperature will be less. The moment when the differences is more in between the ambient temperature and canopy temperature, then if the temperature is lower in the canopy compared to the ambient temperature, it means that water is having good crop is having good moisture, soil is having good moisture, and transpiration is going on. When the temperature increases in canopy also, and there is very less difference, means suppose if I'm saying that 35 is your ambient temperature, and your canopy temperature is also near about 30. 35 is ambient, and 32 is your canopy temperature. It means that now transpiration is not happening in your canopy. So that's why cooling effect is not coming. It means that your plant is under the stress condition. And if suppose 35 is ambient and you are having 25 in canopy, it means that proper transpiration is going on. Soil is having sufficient moisture. That is why transpiration is proper, and that is why cooling inside the canopy is happening. So that's why differences is there. Okay, so this is also one of the criteria that you can use to judge the when to irrigate. And after that, some of the indicator plant is like the sunflower, maize. They will show very, as I told you now, maize is very sensitive to the soil moisture. Little bit variation, the leaves will show the symptoms. So that kind sensitive, more sensitive plant you can use as an indicator plant. Okay. And critical growth stages also is one of the very much important criteria. Most commonly, I can say, if you go in any area, farmers say that this stage is very important because they are knowing that the stages is very important. So that on the basis of critical growth stages, you can say that which one will come up to which stages. So that can be this. Just I'm giving the example. CRI, late early jointing, late jointing, flowering, duff, milking, duff. These are some of the critical growth stages. So according to the availability of the moisture, you can schedule the irrigation according to that critical growth stages, when to irrigate. Okay, so these were all about the scheduling irrigation. Now you can ask anything. After that, we will move for another lecture. I want to interact with you. If you anyone from here,
among participants.
yeah, because it is
something.
very long time now. I'm speaking only, so you people are not interacting. Hello.
Hello, among the participants.
इनका पूरा दिन चलता है क्या लेक्चर?
नहीं, मॉर्निंग सेशन में एक चलता है और इवनिंग में.
अच्छा, मींस 4 घंटे का चलता है इनका.
4 घंटे चलता है.
हाँ, तभी तो ये लोग बोर हो जाता होगा ना.
पूरा बोर होते हैं.
हाँ, मुझे पता है ना, इसलिए जानता हूँ ना. क्योंकि इनके लिए एक प्रेशर हो जाता है ना, 2 घंटे उधर 2 घंटे इधर सुनना. चलो कोई बात नहीं. तो हम तो थोड़ा सा रेस्ट हम भी चाहते थे, क्योंकि हम भी 1 घंटे बोलते बोलते थक गए. कंटिन्यूसली बोलना भी हमारे लिए भी बहुत टफ होता है ना. किसी के लिए भी बहुत टफ होता है, बहुत बोलना पड़ता है, एनर्जी जाती है उसकी भी. अब जो नेक्स्ट टॉपिक हम लोग डिस्कस करने वाले हैं.
प्रतीक्षा, यू वांट टू से समथिंग?
कोई अगर कुछ पूछेगा तो मुझे भी अच्छा लगेगा.
चैट बॉक्स मध्ये. ओके, यस सर.
चैट बॉक्स में
सुदर्शन, प्लीज मेक चेंजेस इन द सेटिंग इफ एनीबॉडी वांट टू से समथिंग.
अब बात कर लेते हैं मेथड्स. माय स्क्रीन इज विजिबल. स्क्रीन दिख रही है?
यस, बट प्रीवियस
दिख रही है क्या?
हाँ, प्रीवियस ही दिख रहा है
अभी.
हाँ,
इरिगेशन मेथड दिखा.
यस यस यस.
तो last time one student asked a question about surge irrigation and cap irrigation. So the answer of that in very clear cut manner you will get in this lecture. Yesterday also I tried to give. So we now understand when to irrigate. So how much we can irrigate, that are these also just you can go for the calculating the just knowing the amount of percentage of moisture in your field, and according to that you need to calculate the amount of water that is required to your field to bring that your field at a field capacity. So different methods are available you can use, and through that you can estimate the amount of the water you need to apply. Now here we will discuss about the methods.
Hello, Vipinji, she want to ask about IWCP ratio again.
Okay, irrigation and CP, irrigation water. You
Yes,
are knowing that amount of water you applied. Suppose I am telling that I applied 400 mm irrigation water. Okay, and now my reading CP cumulative pain evapotranspiration reading, that's come about what I can say. Suppose I'm just giving the example, you must have to understand, because different ratios are already calibrated by the different for the different crops, and when the reading will reach at that moment you need to irrigate. Okay, if suppose your C cumulative pan evapotranspiration value is near about 300, sorry, 1 minute. You irrigated 400 and your CP value is 350. So when you will divide 400 by 350, you will get some ratio, no? It may be 1.2, yeah, it may be 1.5. Okay. So this ratio is also one of the indicator to irrigate the field. So already the CP irrigation water and CP ratio, cumulative pen evapotranspiration ratio, are already calibrated for different crop. Like if I'm giving the example, I think 0.9, yeah, 1 is the ratio for the wheat. This is the ratio when you will get. At that time, you need to irrigate. You got my point now? When you are knowing that you applied 400 mm as a irrigation, and by the calculating your value, cumulative pan evapotranspiration, because suppose this is your field and you fitted your CP pan evaporation here, pan evaporation side by that. So you applied 400 mm as a irrigation. You applied 400 or 40 XY, जो भी value ले लो, you can take. So simultaneously you are also calculating the how much water that is lasting from this pan, and that value, that is cumulative pan, means from irrigation onward you will calculate again next day. Suppose today 20 mm, again next day 10 mm, like that. So when your value, you are knowing that you applied in this field only 400 mm, okay, and you are again day by day you are calculating. When your value reaches, suppose 350, today I got the value, and I'm knowing that 400 we applied. Now if we divide 400 by the 350, I'm getting some ratio now. And suppose it is already recommended that 1.2 is the ideal ratio for this X crop. So you must know that when you get this ratio, now it is time to again apply the 400 XYZ amount of the water again in the field. Hope the clear. So you got clearance about this.
Yes.
क्लियर हुआ ना उसको?
Yes, उसने चैट बॉक्स में दिया है.
हाँ, ठीक है. So in this this is the irrigation method, and actually irrigation method, why is important? Because basically we want to improve our crop water productivity. In the previous lecture we were discussing about the crop water requirement, and the methods what we are choosing to convey the water from reservoir to the field is very important, because that will determine your water use efficiency. As I told you that convenience losses like seepage, percolation, percolation, evaporation, this is the losses happen when the water are transferred from one place to other place. If I'm giving you the example of canal, in the canal you may see that large area that are exposed to the surface, and evaporation happened, and simultaneously side by side seepage also happened. So losses happen more and more. That's why better most efficient method we need to choose if we are really interested to what increase the crop water productivity. So what is crop water productivity? It is the measure of economic and biophysical gain from use of unit of water consumed in the crop. Why this definition is very important? Basically, we are agriculturists. We are always given an assignment to produce more from less. If you are practicing in this manner, then you are a good agriculturist. And if you are producing less by expending more, means you are not a good agriculturist. So how the methods will play the role to reduce the water of consumption, and the methods is very important. So here, and in the yesterday lecture I was talking about how the competition of this finite resources, because we are having surface water finite resources, groundwater is also finite. Now most of the Punjab and Haryana and even Western Uttar Pradesh, and even the rest of the India also started to face the water table depletion. Water is now depleting, and that going very deeper and deeper. Why? Because there is huge competition from domestic sector, from industry sector, from agriculture sector. They are competing for the water. Agriculture ministry will ask that no, this is the water requirement I need if we want to fulfill the food requirement of our whole country, because this is, and domestic sector also population is, so there is a finite resources, water resources in this. Because of saving from that saving us from that competition, we need to choose some most efficient technologies, I means methods. And rising demand of agriculture, as I told you that population, if it will increase, then definitely we must go for the more either intensive cropping system. So whenever we will intensify the crop, then definitely there will be a chance, of more demand of the water, because without water you cannot grow. So there technology will also playing very important role. The efficiency you will achieve, suppose you save 20 liter of the water as compared to the traditional methods you are adopting. So that 20 liter of the water you can use in another crop, most economical crops, to produce, intensify your area. And devastating impact of the climate change. Even the climate change is also, is the one of the very important aspects. And because of the climate change, we are facing drought, lower frequency, uneven distribution of the rainfall. So that's why increasing crop water productivity by use of this different efficient methods is very important. And what advantages you will achieve? By increasing crop water productivity, you can economic stability, social stability, ecological balance, and integration of technology you will achieve. I think I choose in. Here is the from where it is starting now. Base in surface. Yeah. And now there is the some of the methods, well-known methods. Those are very commonly, like surface irrigation is the most well-known, and this is widely used and can be practiced without high technological, but it is labor intensive. So far, India is following surface. Most of 60 or you say 80%, 70% area they are following surface irrigation. Very less, even after the green revolution of what I can say 40 years it happened. So, but still we are following the surface irrigation, and this needs proper design, like slope and level, and because of this more labor intensive approaches, this is one of the costly approach, because more labor when it will be involved, then it will increase automatically your cost if you want to irrigate more area. And basically three system like basin, border, and furrow. This is the so in basin, what you will do, this is a basin area, and the field must be level and encompassed by the dike, and it is favored by moderate to slow intake soil and deep rooted and closely spaced crop. Those are deep rooted and closely spaced crop, and soil, those who have this slow intake, for that soil, for that kind of soil, basin method is very effective. And effective method of leaching the salt from the soil profile into deeper groundwater. You can even, if anyone share you that by the leaching of salt by the irrigation from your field, which one of the methods of irrigation you will use, methods you will follow. So basin is the best, because here you will create some larger basin and you will pond the water. Depth of the water you will maintain here, and you will left it for some of the time. So what will happen then? Your salt will leach out from the field. Can be automated with expensive flow control at the basin inlet. Dike must be well maintained to eliminate breaching and waste, and it is difficult and often infeasible to incorporate the use of modern machinery into a small basin. And so actually this is the as I told that this can be also interlinked with some of the modern technology, but for a small basin it is very difficult. Now we can see here the furrow irrigation system. This is just a construction of a small channel. Here what you will do, a channel you will make different furrows. So your sowing must be your sowing should be here only, and you need to apply the irrigation in that furrow, and can be used in conjunction with basin and border to overcome the topographical variation and crusting. So actually if suppose you are having very large area, because you are making the furrow, and there is some topographical constants, you may also go for the basin inside that only. Suppose you made a basin, large basin, and in that you will make a different furrow. So this suppose this is the basin, so this will have a similar elevation, and this area will have the similar elevation. So you need not to make just for a long from here to here. You may just can divide your whole field into different basins, and inside that basins you may make the furrow. So that's why those variations are available in field in like your field is not leveled well, so that you can minimize by use of basin, and then you will make the furrow. And it is again more labor intensive border basin system, and a smaller wetted area can reduce evaporation losses. So here we are allowing a smaller wetted area, so that's why evaporation losses will be low. Salinity hazard, limited maximum mobility, and increased erosion potential. The problem is that, or you can see even by the use of, suppose you are advantages is when you will use this furrow methods. In this method salinity you can minimize, because this is also a part of the consumptive use of water. When you will plant your crops, suppose your area is affected with the salinity water, so you need to make a furrow and you need to plant or sow the seed side by the furrow. So what will happen? Through the evaporation, the salt will be accumulated over the furrow, okay, and the crop will be escape from the salinity problem. And the reason is that it is also having the more chances, because here you are making more and more furrow, the chances of the erosion will be more. In the case of if you are water erosion will be more, and this is well adapted to row crops and orchard and vineyard. So now we can talk about inside the surface irrigation. There is the border irrigation. Border, you need to make a border, and side by the border you need to plant the trees or any crops, okay, and in that basin you need to, in long border you need to apply the water. Now expansion of the basin irrigation for crops which do not tolerate flooding. Long rectangular and contoured field shape and longitudinal grid, no lateral shape. Field is divided into the strip like 6, which may be vary from 3 to 30, 6 to 30 meter, and separated by the border. And strip between the reeds are flooded during the irrigation. This is used for the tree crops, which are small grain crop. So inside that you can grow the small grain crops, and the border side you can use some tree crops or orchard crops. And even we can classify the irrigation just like manual irrigation. Here I am giving the example, some of the example I will give you, like the pitcher irrigation, water irrigation, low cost drip system. This is the manual type of the manual irrigation. And even though the labor requirement is very high, but this type of the irrigation is very suited for the hill area, and suppose the land holding is lesser, okay, and there may be the problem of water erosion. You cannot store the water in that area, so you can go for this manual irrigation. Here I will show you. This is a low cost drip irrigation system. So here the simply you need to and especially suitable for the kitchen gardening and like that area. So here this is the 500 or 1000 liter of the drum you need to just arrange, and you need to give some of the height so that you can maintain a gravity flow. So through the gravity flow, no need to apply any motor and anything. Just because of the gravity, you are allowing the water to flow through that drip. So this is the some manual irrigation system as a part of smaller, and this is the one example of pitcher irrigation. So here what you are doing, and especially this is suitable for the tree crop and dryland area. What you will do, you just simply place the porous clay jars or pots in shallow soil. Here you need to put porous pit, clay pit, and you need to apply the water only here. And this will be side of the plant where the plant trees are growing. So you are applying the water, and then again you have to cover. So what happened? Slowly water will go and available to the plant root. This is also a kind of manual irrigation. Bottle irrigation is also very now a part of plastic management. Now the many, even social media and all the things, you might have been seen that many people are making bottle as a reuse for the irrigation purpose. But it's, again, I'm saying that these all of the manual methods require use labor, and this cannot be managed for a larger area. This is possible for a small gardening and like that. So here just simply you can use the bottle and insert that in the root system inside the soil, and you need to apply the water here, and there will be the pores, some holes here. So water will just slowly available to the plants. Now here you can see this is a porous section pipe. So here before that I was talking about the bottle and clay pits, but you can use also the pipe also to apply the water. Here what, instead of the pitcher and bottle, porous pipes are used to spread the water along the horizontal line. The pipes are placed between the row crops. So here you can see this is the pipe, and one end is made protrude above the ground to refill it, and this method is just distribute the water over the whole length and not only where it is perforated, and irrigation effect is lower. Yeah, actually you can see the basically here's a two type. One, you can put the pipe, porous pipe, between the two crops where it is growing. So you are applying the water here, and this pipe is porous. The water will slowly seep, and it will be available to the this both row crop. And even you can also do, you can use porous pipe inside that, and you can plant your crops above that. So your root will get benefit from this water. You are not applying water here, you are applying inside this porous tube, and water is coming in this tube, and the water is seeping from here, and it is making available to the plant. So this is also one of the, and even plastic pipe you can just put here side by that. This is also one of the method of the manual. Now we can go for the automatic and high automatic irrigation system, high tech solution. And here these in this automatic irrigation system, these are the totally computer based and some more motors and technology intensive. So here you can see here the automatic irrigation system will have some of the sensor, those are installed in your field, and that sensor will give some message to your operating system, and that operating system will decide how much quantity of water your field is your need of your field. So accordingly that water will be released from your pipes, and that will go to the field. Here I will show you the some of the grid system, how you can see in the cookie. This is totally computer based integration or control system. So you can see so many grid system. It will be available here. If you come at WTC, there is one PFDC, Precision Farming Development Center. At that time, at that field, whole the farms are interlinked. Means in the field there is a sensor, and that sensor will give some message to the your motor, and motor will automatically start. So this is a part of precision agriculture, but so far now I can say that this is not practically feasible right now in Indian condition at a field level. But this is the future when we will go for the more precision, and even this is a very much practical for the foreign country, the developed country. They are adopting this type of a technology and they are practicing it over their field to irrigate the field. Because in this system, in developed country, they are not having manpower too much now. So that's why they are totally depending on the machine to apply the water. So for that condition, it is very much convenient. I cannot to go further too much about to what is the advantage and disadvantage. You may know that the advantage and disadvantages may be vary. In our case, we are having huge amount of the labor. So you may and we are having lesser fragmented land, smaller land holding. So no doubt the system, those are not automatic. That will fit it our situation, but those are automatic and they are suited especially for the area. Those are highly prosperous, large land holding. Now we can talk about another irrigation. This is the sprinkler irrigation, and here is the some of the component you may knowing like there will be sprinkler head, central pivot, linear move, and traveling beam gun and side roll. These are the some of the component of your sprinkler system. I will show in the sprinkler system the main mode of water application is in the form of rain. A sprinkler means in the form of rain. You are not spreading the water just in the form of the flow. You are applying the water in the atmosphere above the soil, and that is falling in the form of as a rain spray. So, and there will be the head size. It may vary. If it is your small heighted crop, so the head you can reduce. And if it is large heighted crops, so you can increase the head. And this will be having some of the dia through that diameter. Under that it can be reduced, irrigate. So accordingly that you can decide how many lines you need to spread in your field, and especially it is used in the garden, pasture, and large area. If you see in the most of the lawn and what I can say field management, where they are maintaining a lawn system, they are using this sprinkler system. And now most advanced system are available even in the case of sprinkler also. Very and that is also even sometime you may see that it is also automatic system. Automatically in morning the sprinkler head will increase and it will irrigate the whole land system, and automatically it will go inside the below the ground. So you cannot see the sprinkler system. And if in golf field, those are highly undulated now, where the irrigation is possible by this sprinkler method. And if suppose your area where you want to grow the crop like undulating area, so in that case also sprinkler is the one of the best method. And central pivot system, this is also a form of sprinkler irrigation, but here the difference is that here there will be some wheel, and this is a central pivot. Main water will be flow here, and here there will be some of the water falling system, like the water will fall in the form of rain only. So here we are not throwing the water above the ground. We are just applying the water inside this central pivot, and this is all water is falling in the form of rain, and wheel will rotate. It will rotate here, the whole field will be irrigated. So this is also very common in the most of the developed country, where they are having kilometers to kilometer of the area, that farm area. They used to irrigate their whole field by this method. There will be some wheels, and that wheels will run and not walk throughout the whole field, and the whole field will irrigate. So this is a central pivot system. Here you can see this is the wheel. Here these are the attached. These all are attached among themselves, and you can see how much area this is covering just by the central pivot. And this will move this side from here to here. Inside that it will go. And even gun, many guns are also nowadays available, and that gun are used to spread the water in the form of rain over the field, and maximum area to irrigate by this is the 0.3 to 0.4 kilometer per gun. You can see. So this is also having the more potential to irrigate maximum area by use of this gun. And this type of the irrigation system, even you can see in India also. Nowadays, farmers are choosing this gun system because this is not much costly as compared to the central pivot system. This can be easily even assessed by a medium class farmers also. So this gun will, on this wheel, it will rotate in your whole area, and it slowly it will irrigate. So there is a pros and cons of the different this sprinkler irrigation. Like you may already I covered in that, because when I was explaining about the sprinkler system, what are the advantages? Advantages is that means you can use it anywhere, like undiluted land, and the main disadvantage is that this is also requiring high cost, because you need some motor and some initial investment, and for a small plot it is not even still feasible. So this is some of the advantages, as I told you, that it is very efficient for the undiluted system. Now we will talk about the drip irrigation system. So drip irrigation system is totally different from the other part, because there we are applying continuous flow, but in the case of drip system we are not applying the water continuous. We are dripping. We are allowing the water to slowly in the form of drop, and there will be also need of some initial investment, because you need some pressure, compressor, motor, filter, different units are there. So here you can see this is the drip system. Under the drip system, there will be the one emitter, and that will emit the drop very slowly, and it will slowly make wetted area around the only crops. So this is so far one of the most efficient technology we are right now having, and you know that this technology developed by Israeli engineer, and this is also by the just by randomly by instantly he's visualized that some of the trees are plants in a dry area that is seeing very green, and when he investigated, he found that from a hillside, a very small water that is dropping side by that. So by taking that concept, that Samcha Bloss developed this system, drip system. And if you see the total potential area that can be brought under the micro irrigation drip and sprinkler in India is 42.2 million hectare land. However, only we are having 3.9 million hectare of land, and that is 9.2% of that is potentially currently under the micro irrigation system. So we are having area where we can go. Even Maharashtra, your state is very number one state for this drip micro irrigation system. And this is the component of the drip system. You can see this is the filter system, sand filter system, and water is you need to pump from this side, and then it will go, and the pressure we can measure how much pressure is required to maintain that, and finally it will come into the form of drop. Nowadays the technology is totally advanced, and even the low cost drip system is also available. Previously it was very costly, but nowadays many things technology had made modification now which is feasible, and you can easily assess it, and government is also giving many subsidies over this. And as I was talking, even you can see the small scale modified man-made drip system you can make if you are willing to irrigate a small area like kitchen gardening. So here the main player will be the gravity. Here we are not using, as I was talking in the previous slide, that manuals way. That is even the labor intensive, but the advantage is that you need not to apply motor, electricity, any energy, just because of the gravity flow. You are supplying the water and it is going to irrigating the field. So again, is also having the pros and cons, and we will not. After that, there is a subsurface system also. Means we were talking about the surface, but in the case of there is a design, we can apply the drip system inside the soil, and we can make a furrow. And inside that, the drip system that will give the water, and in this what we can say, this risk, we can sow our crops. And this type of the irrigation is known as subsurface irrigation, where we are not applying the water over the soil, we are applying the water within the soil. So this is the design of the subsurface. You can see here. We will bury some pipes inside that, bury laterals. And this is also having the pros and cons. There is a chances of the risk of clogging, salt maybe accumulate nearby the emitter, and emitter can be damaged and can be blocked by the root hair. There will be chances of some suspended organic material. Main disadvantage of the sprinkler and drip system is that because here we are applying very less pressure. So because of the less pressure, there is chances of the algal growth. So algal growth, when it will increase, so it will block your pipe emitters. That's why again we need to bleaching of our pipe, so that all the algal growth can be reduced. And the chlorine is the one of the most commonly used chemical that we use for the cleaning of our drip system. So these were all about, but one the question yesterday, one was asking about the cap irrigation and surge irrigation. The system I haven't covered here. I will tell you about here only. He was asking about surge irrigation. Surge irrigation. Surge irrigation is also a form of furrow irrigation. What I was explaining you here, the water you need to apply inside that. But surge irrigation is different than your furrow system. Here what we will do, we will apply the water not continuously to the flow. Here we will block and we will maintain high velocity here, and we will for a short period of time use quantity of water, means through a high velocity we will apply. So when the flow rate will be more, then what will happen, the water will reach at the tail point very in the short period, and again we will block. Okay, then we will allow, after some time we will apply the water into another. Just by the basic principle behind this surge irrigation is that we need to apply the water when after attaining some particular head, so that use quantity of water there will be, and the water will be at a high velocity, so that the furrow end we can go very fast. So slowly we will not apply inside that. We need to apply very fast. So what will happen, and again then we will stop. So what will happen, when the speed will be fast, the chances of deep percolation will be less, and soil water will infiltrate uniformly over the all. Suppose water is coming from this side and you are allowing in this flow. Okay, water will infiltrate and become the part of the soil moisture. Again, there will be the cycle, and cycle may vary 30 minutes to several hours. It is dependent on the size of the plant. Again, we for a short period of the time with high velocity, we apply the water in this furrow. Again, then we will apply in this and this. After maybe the size, it is dependent on the size of your field, how many furrows you are having. After 30 minutes, you may again apply the water in this. So what will happen? Basically, we want to make uniform infiltration of the water in the whole this furrow in the intermittent manner, not a continuous manner. So that is the form of that we call surge irrigation. And he asked one cabligation. Cabligation, there will be one pipe. Okay, and there will suppose here is your field. This side is your field, and suppose you maintain this is your strip or furrow, anything. So there will be some clogging stopper at this side, and water will come from this side, and this will be having some wire reel, and you can just pull it. So what will happen? Water will go at a slow speed from here, and when it is blocked by here, this is a blocker. So automatically what will happen here? Automatically when water will come, when it will be blocked, then water table will be somewhat, it will be rise here. So there will be some opener in each this plot. Okay. So automatically what will happen at the end where water will be blocked, at that side water will rise, and in this side water will be in this manner, because here it is flowing and it is going to accumulate here. So what is when it will rise here, then it will start to flow in this field. When he know that now this field is irrigated, then what he will do, he will pull this wire, and then again its blocker will come up to this position. Now water will start to accumulate this side, then again it will be rise, and then through this opener it will start to irrigate this field. So again it will pull, then again it will come here this side, then water is flowing continuously from this side, and here it will again rise and it will come through this outlet. And basically we want to reduce the manual labor. You need not to go again and again here and open that, and just simply by one automation, but by manual, you can just by pulling this, you can control the flow of water in your field. Because here is the blocker, it will block the water. It will not go here because this here the irrigation is complete. Now he remove here. So here it will rise. Again it will here. Then again here. In this manner, he will irrigate the whole field. And this method is known as the cap irrigation. Okay. So now I think this is finished. If you have still we are having 10 minutes, you can ask any queries or question if you are having in your mind.
Thank you, sir. Thank you very much. Among the participants, if anybody having any query, they can ask to the speaker, or they can also put their questions in the chat box. Lokesh, you want to say something? Okay. I think everybody get clear idea about irrigation methods and irrigation water management. So,
Hope so.
Okay.
All are in the sleepy mode, I think. Most of
this
because this is the
very much
disadvantage is also that from a remote place I am giving a lecture to the Maharashtra. But disadvantage,
Yes,
the
yes.
physical mode is always enjoyable, and this is the virtual mode is very pathetic to listen. I can understand, because we are also handling many meetings, many classes through the virtual mode only now.
Yes. Hope so
I
in
can
the next year
understand.
we will have offline session.
ये क्या बोल रहा है भाई, कोई है सर? Could you please explain IW and CP ratio once again in Hindi?
नहीं
कौन है?
वो
हो चुका है क्या?
क्वेश्चन
वही है क्या पूछा था? प्रतीक्षा काले, तो उसको समझ में आया था कि नहीं आया था?
यस
आ गया। यस सर, थैंक यू। अच्छा, हिंदी, सॉरी मैंने हिंदी में पढ़ा नहीं तुम्हारा मैसेज, तो मैं इंग्लिश में एक्सप्लेन कर रहा था। सीधा सा कंसेप्ट है, इरिगेशन वाटर तुमने जितना जैसे अब तुमने 400 ml जो है तुमने अप्लाई किया, साइड में तुमने कम्युलेटिव पैन इवापोरेशन रखा है। जिस दिन अप्लाई किया उसी दिन से तुम उसकी रीडिंग ले रहे हो कि कितना वहां से पोटेंशियल इवापोरेट ट्रांसपैरेशन हो रहा है। ठीक है, तो जब तुम्हें पता है 400 mm तुमने इरिगेशन दिया है, और मैं भी 5-6 दिन 10 दिन बाद तुम्हें ये लगेगा कि नहीं यार हमारे पेन से 350 या समथिंग अमाउंट लॉस हो गया। अब तुम क्या करोगे, कितना अप्लाई किए हो, जब उससे डिवाइड करोगे तुमको एक रेशियो मिलेगा, और हर क्रॉप्स के लिए एक रेशियो ऑलरेडी कैलिब्रेटेड है। जब तुमको पता है कि ये तुम्हारे क्रॉप्स के लिए ये रेशियो है, अगर तुम उसके क्लोज आ गए तो इसका मतलब ये है कि तुम्हारा जितना पानी डाला था वो लॉस हो चुका है, रेशियो आ चुका है। तो वो रेशियो एक इंडिकेटर होता है किसके लिए? इरिगेशन शेड्यूलिंग के लिए।
Yes, definitely. With this, I request Mr. Sudarshan Shinde to conclude the session. Sudarshan, you are there? One question is there, sir. How we can schedule irrigation by sunflower?
अच्छा, बारदे ओम बारदे। देखो हमने जो बात किया था, जैसे कि कुछ क्रॉप्स होते हैं जो कि मॉइस्चर के बहुत सेंसिटिव होते हैं, ठीक है। अब उनको क्या है, एक इंडिकेटर प्लांट यूज कर सकते हो जो सेंसिटिव हो, इंडिकेटर प्लांट है। अगर सपोज दैट सनफ्लावर के टाइम पे ही, जैसे जैसे क्या कहते हैं, तुमने लगा रखे हैं वीट लगा रखा है, एग्जाम्पल के तौर पे मैं मान रहा हूँ, ठीक है। तो वीट के फील्ड में साइड बाय कहीं कहीं पे सनफ्लावर के प्लांट लगा दो। तो सनफ्लावर क्या है, ये सेंसिटिव है, ये सिम्टम जल्दी शो करेगा मॉइस्चर का। जैसे तुम्हारा वीट है जो, वो थोड़ी देर बाद शो करेगा कि वाटर की डिफिशियंसी है या नहीं है, लेकिन उससे पहले चिल्ला के यही बोल देगा कि नहीं नहीं नहीं, फील्ड में पानी कमी हो रही है। समझ गए ना। तो दो ज्यादा सेंसिटिव क्रॉप, उन सेंसिटिव क्रॉप्स को तुम ले सकते हो एज ए इंडिकेटर। जैसे एग्जांपल के तौर पे सनफ्लावर और मेज, ये दोनों सेंसिटिव हैं इंडिकेटर, तो इसलिए इनको इंडिकेटर प्लांट ले सकते हो।
Yes, definitely.
आप समझ गए होगे।
Any other? Okay. Okay. Sudarshan, you are there? Sudarshan Chande?
Yes, sir, I am there.
Okay, please conclude the session.
Yes, sir. On the behalf of MPKV Rahuri, Post Institute, and the Department of Extension Education and Communication, I would like to thank you, Dr. Bipin Kumar sir, for hosting these sessions for method of irrigation, measurement of irrigation water, application, distribution and its efficiencies, conjunctive use of water, irrigation water quality and its management. Sir was very, this session was very effective. Students and other participants get properly knowledge and very much get proper information regarding this course and this method of irrigation and measurement of irrigation water. I'm very thankful to Dr. Bipin Kumar sir, and I'm very grateful to him and grateful to also MPK Rahuri for hosting such knowledgeable and very informative lectures. Thank you, sir.
Thank you.
Thank you, sir.
Okay, thank you, Prashant ji. Thank you. Thanks
Yes,
for giving me
definitely.
this
I will call you.
opportunity. Okay. Bye bye.
Thank you.
Thank you, sir. Thank
You can leave now, sir.
Yeah. I'm leaving.
Sudarshan, please.